Hello dear students. In this video, we will be doing the proof of converse of BPT, which is the reverse or opposite of BPT, basic proportionality theorem. After watching this video, you should be able to write the statement of converse of BPT and prove converse of BPT. In order to prove converse of BPT, we will use a concept from basic proportionality theorem, BPT, or the Thales theorem, which has been proved earlier. This is the statement for BPT. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. If we'll consider this figure in triangle ABC, if DE is parallel to BC, then the ratio of AD by DB will be equals to AE by EC. This has already been proved, and the link for the proof of this theorem is given in the description, so you can check again. So now let's prove converse of BPT. Let's start with the statement of theorem. Converse of BPT states that if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So the statement is just the reverse of BPT. That's why this theorem is converse of BPT. So let's consider a triangle ABC, and as per the statement, we have a line which is dividing two sides of this triangle ABC. Here, line DE is dividing the two sides of the triangle ABC, AB and AC in the same ratio as AD by DB equals to AE by EC. We need to prove that DE is parallel to the third side of the triangle, which is BC. Given to us is triangle ABC and line DE intersecting AB at point D and AC at point E, such that AD by DB equals to AE by EC. We need to prove DE is parallel to the third side of the triangle, which is BC. In order to prove it, let us assume to the contrary that DE is not parallel to BC, and we will assume another line DE dash parallel to BC. Now, by BPT or Thales theorem, if DE dash is parallel to BC, then DE dash will divide the line segments AB and AC in the same ratio as AD by DB equals to AE dash by E dash C, as DE dash is parallel to BC. So we are applying Thales theorem or BPT. Let us keep this equation as equation number 1. But it is also given that AD by DB equals to AE by EC. This is given in the statement of the theorem itself. Let's give this as equation number 2. Now, on comparing equation 1 and 2, the left hand side of both the equations are same, that is AD by DB and AD by DB. So this means the right hand side should also be equal. So from equation 1 and 2, we will get AE by EC from equation 2 equals to AE dash by E dash C from equation 1. So AE by EC will be equals to AE dash by E dash C. Now on both sides, if we will add the numerator and the denominator, AE plus EC, on adding the two, we will get the entire length AC, the entire side AC, and similarly, on adding AE dash and E dash C, we will be getting AC only, that is side AC only. AE plus EC as well as AE dash plus E dash C is giving us AC. So let's evaluate the two sides. Now, in order to derive AC in the numerator, let us add 1 on both sides. So we are adding 1 to both sides of the equation. On doing so, first on the left hand side, AE by EC plus, we can say it's 1 by 1. So EC is the denominator of the first quantity, and since it's just 1, that means the denominator is 1 only. LCM of EC and 1 will be EC, and in the numerator we'll have AE plus EC into 1 is EC. Now onto the right hand side, we will have E dash C as the LCM. So AE dash will be as it is, plus E dash C into 1 will give us E dash C. Now the numerators of both sides will add up to AC. AE plus EC as AC, and AE dash plus E dash C also as AC. So we have our equation as AC by EC equals to AC by E dash C. Since the numerators are same on both sides, we can cancel out AC from both sides. So our equation has reduced to 1 by EC equals to 1 by E dash C. Now on cross multiplying, EC into 1 EC equals to E dash C into 1 E dash C. E and E dash are points on the same line segment AC, and the distance from E to C and distance from E dash to C is coming equal. But this is possible only if E and E dash coincides. That is, if E and E dash are the same points, then only the distance from E to C and E dash to C is going to be equal. So we have proved that E and E dash are the same points. And we had assumed DE dash to be parallel with BC. Since we have proven that E and E dash are the same points, so we can conclude DE is parallel with BC. This proves the converse of BPT. Now work on the proof of this theorem. Thank you and have a nice day.